Today's lesson is on direct variation. Direct variation is two quantities, x and y, that show a proportional relationship when one, the graph on the line passes through the origin, and two, the points are proportional to one another. So one way to tell if x and y show direct variation is to actually graph them and then determine if they show it. So if you're looking at like number 1 here, and we want to actually graph these points and see if they show direct variation. So graphing the first point, so it's 1, -2, so over 1, down 2. The next point is 2, 0. The next point is 3, 2. And the last point is 4, 4. 1, 2, 3, 4. 4, 4. Whew, there it is. So if these points pass through the origin, they show direct variation. Or if the points are proportional to one another, they show direct variation. Unfortunately, this one does not. This is a linear function, but it does not show direct variation. And what direct variation really means is if you have an equation that's written y equals, and we call it k for the constant of proportionality, it's also your slope, y equals kx. It means that whatever I put in for x directs y or affects y directly. Like I take x and I either multiply it by 3 and I get y, or I divide it by 2 and get y, or I multiply by 17 to get y. Direct variation is always going to go through the origin, okay, which is your point 0, 0. So because this does not go through the origin, and because my points are not proportional to one another, this one does not show direct variation. So let's take a look at the next example here. Okay. So here we can see the point 0, 0. We can see the point 2, 2. 4, 4, 6, 6. Again, we have a linear function. We have a linear equation. This one does go through the origin. Therefore, this does show direct variation. What I do to x, I get y. So it's like I'm taking x and I'm timesing it by 1 and I'm getting y each time. It's not adding 2 or subtracting 6 or anything like that. It's just being multiplied by 1 each time to get y. So yes, this one does, because it does go through that origin as well. So another way to determine if it is showing direct variation is to use a table. So when you do this, determine whether x and y show direct variation in the table, simplify each ordered pair. If they are the same, then the relationship varies directly. So I always like to take slope, which is your ratio of y to x, change in y over change in x. So I'm going to take the slope here and I'm going to say, oh, okay, so the slope of the first point is 4 to 1. The slope of the second point is 8 to 2. Third point is 12 to 3. Fourth point is 20 to 5. Do these show direct variation? Well, let me reduce each and every one of them. And yes, they do. The reasoning behind it, because, I'm trying to make my comma there, they reduce the same. Therefore, they're going to show the direct variation. They are proportional to one another. Looking at number 5, you can just look at those and you have 5 to 3. 7 to 4, 9 to 5, 19 to 10. These are not going to reduce to the same thing. Sure, they may create a linear function. Sure, they might have a pattern and they could make a straight line when you graph them, but they do not show what is called direct variation. In order to show direct variation, they have to reduce the same and they have to go through the origin. So right here in number 6, you can pause the video if you don't want a spoiler alert. But in number 6 here, you can see right away, 0, 0. They go through the origin. You can also put y over x, and you can see that you have 12 to 1. In each time when I reduce them, it's 12 to 1, 12 to 1, 12 to 1. So yes, number 6 is going to show direct variation. What I do to x directly affects y's value. Okay. So the graph below models the relationship between time, x, in hours, Janet works, and the amount of money in dollars she earns. So it says to write an equation that represents the situation. So for this, what you are doing is, if you're looking at this, you will see that I'm going to look and see where does it cross? Where is this going to cross your, like at an intersection between x and y where it is whole numbers? Well, at 0, 0 definitely. So this definitely shows direct variation. But it also is right here. Okay. It crosses at 5, 60. So what this means is that for 5 hours of work, she makes $60. Okay. So your change in y, if it's $60, whoops, for every 5 hours, that means she makes, so $60 for every 5 hours, change in y over change in x, that means she's making $12 in every 1 hour. That's your slope. That's the slope of the line. An equation, indirect variation, okay, because it says to write an equation that represents the situation. Since it is indirect variation, your equation's format is y equals something times x. In this time, in order to get the amount of money, which is what y is, that equals, you're going to take $12 that she earns per hour and multiply it by however many hours she works. So y equals 12x is your equation in direct variation that represents the situation. Interpreting your slope. So what this means is a lot of kids will say, oh, well, the slope is, you know, change in y over change in x. Or the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's not what this is asking you. When you're asked to interpret something, you have to ask yourself, what does this mean in context of the problem? This is your slope right here. Okay, your change in y over your change in x. Your proportionality, 60 to 50, or yes, 60 to 5, 12 to 1. That's what your slope is. So what this is saying, when you interpret your slope, she works, your slope is 12 to 1. So interpreting the slope is she makes $12 per 1 hour. Because your slope is 12 over 1. And what your slope represents is $12 in 1 hour. That is her rate. So how many hours will she have to work to make $120? All right, well, you know your amount is $120. You know she makes $12 per hour. So you just have to figure out how many hours. Now you can divide both sides by 12. You're going to get x is 10. She has to work for 10 hours. Anna makes $10 per hour. Write and graph a linear function that represents her earnings. Compare their slopes. What does this mean in context to the problem? So if you can see that Anna makes $10 an hour, okay, so write and graph a linear function, so you need to write it. So 10 is her constant there. So y is going to equal $10 per hour. That's an equal sign. Okay, so there's her equation. So if you're going to graph this, if Anna makes $10 per hour, well, in 1 hour, and I'll do it in red so you can see. In 1 hour, she makes $10. In 2 hours, she makes 20. In 3 hours, it's 30. 4 hours, it's 40. 5 hours, it's 50. 6 hours, it's 60, so on and so forth. So again, hers does show direct variation. Woo, not a very straight line. But her slope is not as steep. And here's where I would ask you guys why. Her slope is not as steep. It says to compare, and I would say her slope's not as steep because she makes $2 less an hour. So she does not have as steep as a slope because she does not make more than, I don't remember her name, Janet. She does not make more than Janet. So What does this mean in context of the problem? It just means that since her slope is not as steep, she makes less money. So direct variation means that y is being affected by x directly. I'm taking x's value, timesing it by something or dividing it by something, and it's giving me y right away. I'm not adding, I'm not subtracting. My values are proportional to one another, so I can just take my y over x and reduce, and if they reduce the same, it's direct variation. If it goes through the origin, it shows direct variation.